All right, welcome to the Blue Book. We want to review some things with integers, which I know you studied in grade 7 and 8, but it's one of those really important ideas again in high school mathematics that if we struggle with that, we'll struggle all the way through. So often another name for an integer is a sign number. A number, in other words, a number that may have a sign with it. And probably the one that we're most comfortable with, especially here in Canada, is a thermometer, where our temperatures aren't only positive, but they can be negative, which means they're below the freezing point. So if we look at a thermometer, we may have 20 degrees, but is it 20 above zero or 20 below zero? And the way that we show 20 below zero is with a negative. So really, an integer is a name for a positive or negative whole number. Okay. If we look at them on a number line, we would arrange them this way, where 0 is right in the middle, the positive numbers are towards the right, and the negative numbers are towards the left. So what do we want you to be able to do with them? Well, in the next two sections, we're going to talk about adding, subtracting, and then multiplying and dividing. But let's just start off and say, okay, what's the relationship between them? We should be able to order them or compare them. So I put the little thermometer off to the right there, and I say, think about that, or think about the number line. I often like to think about temperature. So if I was comparing -3 and +5, which one's warmer? And the warmer temperature is the greater one, right? So +5 is definitely warmer than -3. So we would say -3 is less than 5, or 5 is greater than 3. -3, sorry. Now, if you're not quite sure how to place that sign, remember the idea that the alligator goes for the bigger one. So 5 is the biggest one, so that's where we put the alligator going towards that one. Now what about this one? -5 and -13. Now right away students say, well, 13 is bigger than 5, and that's true. But think about warmth. Is it warmer outside when it's -5 or when it's -13? Another way of thinking of it is which one's closer to 0? The closer you are to 0, the bigger the number is, right? The further you are towards the right, the bigger the number is. So -5 comes way before -13. -13 would still be down here somewhere. -11, -12, -13, so it would be way over here still. So -13 is actually smaller than -5, or colder than, right? So we would say -5 is bigger. All right. One other idea that's introduced in this chapter is what we call the absolute value, okay, of a number. And the absolute value of a number is really the distance between that number and 0. And the best example I have is if I was to ask you how far you live away from school. You would probably not indicate a distance, but just how many blocks. So you might say I live 5 blocks away from school, or 7 blocks away. You'd never say to me I live -5 blocks away or -7 blocks away. You'd just say 5 or 7. So if I look at the number -4, how far is -4 away from 0? So again, if I look up to my number line, how far is it between -4 and 0? Well, it's 4 units. So we would say the absolute value of -4 is 4. Now students sometimes mistakenly believe then, so I always switch the sign, and no, that's not true, because again, what we're looking for is what is the distance between 0 and the given number. So if I look at the absolute value of 4, I want to know how far is this number away from 0. And again, if we were to look, that's 4 units away. So the absolute value is always positive, always, always, always. It can never be negative. So with that in mind, take a look at these questions then. And really what I want you to think about is which one's closest. So I'm going to just duplicate this number line, and I'm going to bring it down with us so that we have it to compare with. Okay, and the question is, which one is closest to 0? So if I was to compare these two numbers, I have -3 here. Let's put that one in red. I'm just going to circle it. And +5 in green. Which one's closest to 0? Well, definitely -3 is, right? So it turns out 5 is furthest away, so we would put it that way. Okay. Now, -13, well, we're going to run into a problem there, but I can fix that a little bit. I'm just going to slide my number line over. I'm going to extend this a little bit and say, okay, this would be -11, -12, -13. Okay, so -5, I'm going to put that one in red. Circle it. -13 over here. Well, which one is closest to 0? Definitely negative 5. So negative 13 is furthest away. So we would put it this way again. Even though as a number, negative 13 is smaller, it is further away from 0. Now, what about these two numbers, negative 7 and positive 7? And if we were to compare those two, negative 7 is here, positive 7 is here, here is 0. Which one's closest? It turns out they're the same distance away, so we would say they're equal. Okay? Even though in terms of numbers, they're not equal. Negative 7 is definitely smaller or colder than 7, but in terms of their distance away from 0, they are equal. All right, so another important idea is the opposite of a number. And to find an opposite, basically we just switch its sign. So if we looked at the last one, 7 and negative 7 are actually opposites of each other. So the opposite of 4, its opposite is negative 4. The opposite of 7, or sorry, negative 7 is positive 7. So here's what they're going to ask you to do a little bit in this section. What happens if I have something like this, where I want the opposite of negative 6? Well, the opposite of negative 6 is really 6. So what happens when I make life a little more complicated? And now I want the opposite of negative 5. Well, that starts to get a little complicated. Let's just start with the square brackets, and we go, I want the opposite of, well, the opposite of negative 5 is positive 5. And then the opposite of positive 5 is negative 5. Well, another way of thinking about that, as it turns out, is if you have an odd number of negative signs, the result is negative. Now, what's it mean to have an odd number? Well, if you have one negative, it's negative. If you have 3, like we did here, the result is negative. If I had 5, the result would be negative. Now, what happens if I added another one here? Well, if I added another one, I would now take the opposite of negative 5 and become positive. So it turns out if there's an even number, of course, the result is positive. All right? So what's the big deal about numbers and their opposite? Well, here's the big deal, and here's something that we're going to be using throughout this, using colored tiles to show represent integers. So we use black to be positive and red to be negative, just like they do a battery in a car. So if I wanted to show negative 2, it would look like this. And if I wanted to show positive 2, it would be like this. Now, one of the big ideas here is that when I put those together, a positive and a negative result in nothing, and they disappear. Now, why would that be? Well, and if we go back, I say we add a number and its opposite, they become 0. Now, why would that be? Well, think of football. If I gain 4 yards and then lose 4 yards, I'm back where I started. Another example I use is spending money. If I spend $4 and I earn $4, I have no money left, right? I'm back where I started. So a number and its opposite always give me 0 when they add together. And that's going to come back to us again. All right, go to work on Unit 11.